This is the original Stinson factory prior to being in Wayne. It's in Northville, Michigan. It's at 455 Katy Street. It's still there. That picture was taken a couple of years ago when Bill was in town and Maury was up from Australia visiting. Prior to 1920s, it was a furniture factory up there. Stinson moved in. They were there till 1928 when E.L. Cord decided we're going to dump a whole boatload of money into the Stinsons. They built the Wayne factory and airport where the 108s were built. If anybody's ever up in Michigan, it's still there. It's been 2 or 3 different businesses. Last time we were up there, it was a facility where they rented out small cubicles and office space where somebody wanted to have a small business, but they didn't want to rent a whole building. So it was like a shared space. 455 Katy in Northville. Whoop, go back one. That's just a better close-up shot of it with the address. Which is kind of ironic. It's got one of those big, funny-looking gull wings on it, but that airplane wasn't invented till 4 years after they left the building. There's a restaurant called Rebecca's up in Northville, and this sign's on the wall in the restaurant. So when they build airplanes up there on the Katy address, it was downtown. It wasn't built up like it is now, but it was still a downtown area. They had an airport about a mile or so west of town out in the country. They used to trailer the airplanes or drag them out there, put the wings on it, and that's where they flew them from. It was still Northville, Michigan. This is the Wayne facility where our airplanes were built. That was taken about a week and a half ago. The factory, the original portion of the factory is still there. The Quonset type shaped roofs, that was the final assembly hangars. They used to roll them out to the north. We're facing southwest right now. The factory to the right of it, the new modern looking building, was all added on years and years and years ago. It was owned by Ford Motor Company for a long time. Then it was owned by some other manufacturing facility, and now it's all split up into small businesses. You can drive right up to the old factory. It's right off of Van Born and Wayne Road.
Is the water tower still standing?
No.
That's where the 108s were made?
That's where the 108s were made, yeah. That's the side. You can see where the brick is. You go off to the far left of the picture and you can see the different architecture. That's the plant that was added on later. But all the old red brick building, the 2-story, that was the original 108 factory.
Is this at an airport? Or
it used to be their own airport. It was Wayne Airfield.
Okay.
When they built it, it was all wide open. It's all built up buildings now. The runway hasn't been there in 50 years.
So we can't take them home?
You could, but you'd have to trailer it out of there.
Bring it back out there, right?
Nah, they'd frown on it. We used to run into a lot of the old timers that worked at the factory, and you'd corner them and you'd get some of the stories out of them, and it was a lot of good stuff that nothing was ever printed, but they worked there. We ran into one of the guys that he welded the fuselages together, and he was telling us they were all electric welded. They're stick welded, which is really, really strange for an airplane fuselage. And they had a degaussing room that when they get done welding it, they had to run this airframe through the degaussing room, just like you do with Magnaflux, demagnetizing a part. And he said they used to play around because back then everything was a wind-up watch. And he said they could play with the magnetism in their degauss room to get their watches where they're real accurate. So the beam that's coming out of the top, they used to do the fuselages up top from what we were told. They did all the welding, fabrication, then they opened the 2 doors and they had it on a gantry on a chain fall. They rolled them out, lowered them to the lower level, and that's where they did the covering on them and the final assembly. So the upper level was all like a sub-assembly. And the big parts like the wings and the fuselages, they had to get them out of there. They didn't have elevators, and that's how they got them out. They opened the doors and lowered them down, shut the doors, and let the room heat back up. That's another shot of the existing factory. Just on the right there is the 2 Quonset hut building. The same thing, you can drive right up to it.
What's it used for today?
There was a machine shop in there about 3 years ago. They've just done a bunch of remodeling on that front face. It's just been completed in the last month or so. I don't know if anybody is in it right now. I always had the urge to go in there and see if there's anything left up in the top in the rafters, but my guess is I'm not the first one that thought of that. That's
Is the railroad track still run by it? Or
right next to it, yep.
is the railroad track still there?
Oh yeah, yep. That's my straight 108. I've had that, been flying it since '87. I've put about 2,000 hours on that airplane. Been all over the country. Okay, tail wheel. If you look at the parts manual, the attach point for the tail wheel shows the bolt going one direction. The service manual shows the bolt coming up, holding it together, going the other direction. If you notice, it's not an elastic lock nut, it's a castellated bolt. That's the way it's supposed to be wired, and that's the way it's supposed to be installed. You notice there's no grease zert on this one. The grease zert, if you take a grease gun and keep pumping that, getting grease out of it, the tail wheel's never going to lock straight for you. It's always going to kick loose. What we did with them is about every second or third annual, when it's up in the air with the tail wheel suspended, we'll take that off, clean it all out, put a thin film of lubriplate on the little clutch plates in there, the friction discs, put it back together and tighten it up, and it's fine. It doesn't need to be greased every year until grease is coming out of it. It doesn't help it. The chains and the springs, those should have a little bit of slack in them when they're sitting stationary. They shouldn't be under tension. That'll give you about 15 degrees of travel with the tail wheel. Any more than that, you get full right rudder and tap the brake, you'll kick it loose into caster mode. If you've got tension on it all the time, you've got a preload on it and it'll break loose even easier, and it's a real bear in a crosswind. You don't want them tight.
So the rudder horn for the spring attach points, how were they set up initially? Did the springs hook directly onto that?
The springs originally went up, see I've got the eye bolts coming out of it, moving it in. All I did with mine is I got a little too carried away with it and I changed the steering ratio. So it kind of desensitized it. So it's more of a linear push travel.
How were they originally?
The spring was just hooked right up through the rubber horn. Then the chain links came back to the tail wheel.
And then from a legal, not legal standpoint, does it really matter?
What, define legal? I mean, are you using all the right parts? Yeah, it's okay. I mean, you go walk up the line, there's not two tail wheels out there the same configuration. Yeah. But if it works, fine. I'm just saying, you know, from years of experience, this is what we found works the best. You notice the tail wheel tire doesn't have the sawtooth pattern. The old McCreary, the Chenoweths. Come on. Aero Classic makes that tire. It's almost a necessity for the Dash 3s with the big heavy tail. They got a lot more weight on the tail sitting on the ground. If you drop a Dash 3 in with the old sawtooth pattern tires, you can pretty much guarantee you're going to blow the sidewall out of it. Or if you let the pressure get down below 45, 50 pounds. These tires on a small tail, you could almost let the air out of them and use them. They're much, much more durable tire. When you do the annual on the airplane, you want to jack the airplane, the tail up in the air where the tail wheel's hanging, where the tail wheel spring pushes up into the rear of the fuselage. There's a steel box in there. It's a good jack point. Take a hydraulic jack or have somebody lift it up, put it on a little jack stand, get the tail wheel up in the air. At that point, you can start shaking it side to side. With the airplane sitting on the tail wheel on a load, you can't tell if anything is loose back there. By putting it up on a jack stand, getting the tail wheel in free air, you can see if the bushing is worn, the bolts are loose, the rubber coupling that goes up into that box. I've seen those where guys have taken them apart for an annual, and so they never even knew the rubber left. And it's all, you know, it's got a 1/4 inch gap in there slapping around.
That's a real son of a bitch to replace.
It's not fun, yeah. Okay, the rear bolt. It's an AN 5-25 in the parts manual. What we found, whether that was a typo or something has changed, a 5-25 is real tight. It's not quite long enough. If you put a 26 in it, now you notice it doesn't have an A on it, so it's not a elastic lock nut type bolt. It's supposed to be cotter pinned. It's got an AN 310 castellated nut on the other side. This is something that I came up with on them years and years ago after I broke 2 bolts.
I noticed you got bolts with a plate, whereas the airplane that crashed initially had U-bolts.
Mm-hmm. Yeah, this is a very, very early 108. Through the years, things have changed in them, and there's a lot of parts up in the wing that are completely different between an early 108 and a Dash 1 and 2. We'll get to that in a little bit here. Now inside that bolt, there's 2 sleeves. There's an inner and an outer bushing, and it's a 5/16 bolt that goes through there. Guys will put elastic lock nuts on them, and they'll start reefing down on it if it's got a little bit of play in it. That's not the way to fix it, because you're trying to squeeze 1/4-inch steel plate. The bushings are set up. If you buy a brand new bushing from Univar, it's a little bit too long. Guys will grind them off, and it's like, well, no, that's where you put the shims. You take AN 963/8 washers, and when you put it all together, you go in there with a feeler gauge and you figure out how much gap there is, and then you figure out the same thickness in a washer, and you pull the bolt back out and you feed washers in there for a shim, and then you stack it all up together. So that extended portion of that sleeve bushing actually holds that shim washer in place. It surrounds it. That takes up all your side-to-side play. You can't do it by torquing that bolt. This is the other side. The trick that we figured out was you drill the head as well. Instead of putting a cotter pin in it, you come off of the tail, safety wire, go all the way around the loop, go through the head of the bolt, come back and around and safety it back through the same hole. So now you've captured that bolt. So if you're out somewhere and you snap the head off that bolt from a real bad crosswind taxiing, you can picture that 5/16 bolt and you're trying to taxi a 108.3 with all that side load on that tail. It's all being transmitted to that little 5/16 bolt. If you pop the head off that bolt, there's nothing stopping that bolt from coming out the other side. When that happens, your tail wheel leaves. So by capturing it with the wire, you'll catch it on a pre-flight. If you break the head of the bolt or the tail of the bolt, the safety wire is going to hold the remaining portion of it into the bushing and it's not going to come out. That's what it looks like off the airplane. I've got one up here. You guys can come look at it after the presentation. Give you an idea how to do it. And it's like Murphy's Law. If you safety it, double safety it like that, you'll probably never break again. This is the weak link that nobody ever looks at, the flap return spring up in the wing. There's an inspection hole underneath the flat belt frame, and you can look at it. Who's got serial number 183? Okay, mine's 185. The very early 108s, the other end of that spring, the flat bracket, was welded up out of pieces of steel tubing and plate. The later ones, from a 1 all the way up to a 3, was an aluminum forging. And they figured it out in the straight 108s. The outer point where that spring goes in, it starts chewing away. It's metal, steel, and it elongates that hole and starts wearing through that spring. That's something to look at when you get to the end. This one is really, really hard to find. That measurement point's exactly 24 inches in from the root of the wing. And it's ahead of the flaps in that tapered area. Nobody ever puts an inspection hole in there. So the only way to see that inner hole, you can see it, that one's the wing that was just taken out of service, but you can see how elongated that hole is. Nobody ever looks at them. The only way to get in there and look at it is with a borescope. Or you can cut an inspection hole. If you find one that's wore out, you're going to cut the inspection hole back there anyways, because that's the only way you're going to get a new spring in there.
Is that an all 108 or is there early ones?
All 108s on that, it's a steel bracket, and that's attached to the, behind the spar, behind the gas tank. The other end of it,
That's on the back side?
that's on the back side, behind the fuel tank. Okay, this is on a Dash 2. to. That's the flat bell crank. You can see the other end of the spring in there. If you look close where that spring goes through that forge, there's a bushing in there. So even back in the 40s, Stinson figured out that it was going to be a wear point. That there's usually an inspection hole to get in there and shoot some oil in it, lube it, make sure the cables aren't frayed where they go through the guides. The lower wing strut attach point cluster, if you're going to get in and do an annual on the airplane, take a real good look. That's an area that's susceptible to corrosion. Been a lot of them that the guys have found them after they bought the airplane. When they finally open it up for an annual, they never looked at it before they bought it, and they find out that that cluster is all rotted out. If the airplane's been looked after and it was primed and dealt with accordingly when they recovered it, it shouldn't be an issue. But if the airplane's been left outside in the dampness and the weeds, you're going to get corrosion in that tubing. AD note on the rudder cable pulleys. The original pulley was 2 inches in diameter. It was an AN 210 part number. There's the Piper service bulletin. We get back to the same thing. All this supersedes the manual. The AD note refers back to the service bulletin for compliance. Easy way to tell the difference in them, other than getting in there with a tape measure, is below the bolt. You can see where it's got that little chamfer. It comes down and then it loops around the back side. It's a one-piece captured pulley. You can't drop the pulley straight down when you pull the bolt out. It's got to slide forward or back to come out of the slot. Once the pulley has been changed to the new style, you cut that lower section off. The new pulley, the Piper part number is there, and it uses two SK253-2 guards. They bolt under the head and the nut of the unit, and they sandwich it on there, but it's a 2.5 inch diameter pulley. The larger diameter pulley had less tendency to fray where it went around a tight radius. When you guys are doing the annual on it, the best thing you can do walking around and crawling around in the hole looking at cables is take a clean rag, soak it in engine oil, and wipe the cables down. Run them away from the pulley where they're not in the natural state where they sit, and run the oily rag along there. If there's any fray starting, you're going to catch it on the rag and you won't rip your hands open. But it's a good way to find the frays that are starting. And we've seen them all over. We've seen them there. Another one is up in the corners behind the rear cabin where they go up into the fuselage, the aileron cables. The aileron cables where they, in front of the yoke, you got your two pulleys and your crossover. We've seen them that they're frayed in there. I mean, it's not a normal area to wear, but you got to realize these things are 75 years old, and there's a lot of these cables are still original cables in them. Landing gear fairing bracket. I've got one up here that you guys can look at after. Gear length fairing bracket. If you fly strictly off a paved runway, they're pretty good. They don't break a lot. If you fly off unimproved strips, just about guaranteed that when you pull the lower landing gear strut cuff off and look, one of those legs is going to be busted. Univer still sells them. It's just a given. Welded, patched. About 20 years ago, I got tired of doing that, and I repaired mine. I used stainless steel worm gear clamp material and 3 floating number 10 box nuts, and I duplicated it, so now it's not rigid. I haven't touched them in 20 years now, so that cured it. I've got one up here if you guys want to take a look at it after. And you're not manufacturing a part, so you don't worry about PMA, you're repairing it. It's using the existing clamp. I just repaired it and put better legs on it. That's the big flaps. The picture was for the gas tanks. The fabric over the gas tanks airworthiness directive only applies to 108 2s and 3s. Nobody can tell me why, nobody knows. It's probably got something to do with the air speeds. You can have fabric covering over a -2 or a -3 fuel tank as long as the wing was covered with the fuel tank out of the bay. You take the fabric with the gas tank out, you go down, you glue it down to the spar, go forward, and then tuck it down around the bottom of the gas tank. And then you install the cork and you put the fuel tank in. Do the same thing all the way around it. And then put the gas tank in. You put the covering over top of the gas tank to make it look nice to match the top of the wing. That's legal. You can't put the gas tank in the hole and then put a big envelope method on the wing and cover it. Because if that wing comes loose from the gas tank, the fabric, it's going to peel it from the airplane. So you can have the fabric covered gas tanks as long as they're secured to the spar all the way around. The airworthiness directive calls out exactly what's allowed and what's not.
That's your extended flap, right?
Yeah. And it's legal.
Is that field approval?
Yep.
How much of a difference does that make? Huge.
We'll go over that after. Let me get through this. The original breather hose coming off the engine was this spiral perforated stuff, and it was really good, except it's porous. So you get all this oil drizzling down the back of your engine and you can't find the oil leak. Run your hand along the bottom of that aluminum tube and it's going to be wet. That's where the oil comes from. That worked really good for a blast tube for the generator, but that's about all. That's the best breather hose. It's Mill 6000-14 7/8 ID. The other trick with it is when you come out of the breather cup, come through here, a lot of the guys will dump them right down as quick as they can. If you get that up, that arch as high as you can until you just close the cowling and it touches the cowling, you're going to eliminate a lot of the blow-by that's going down the belly because the oil's not going to run uphill to go out. That's forward of the engine bay. That's that Mill 6000 7/8 hose. You can actually see in that where it's coming out of the breather cup and it's already going uphill. That's the TransDapt oil filter housing. That was done, I don't know how many years ago. That was before Airwolf was in existence. And it's just a standard race car housing. We did a field approval with it. The Challenger, the aluminum oil filter is one that I put on about 6 years ago. Now the Champion filters are up to $35 with shipping by the time you get one. If you change the oil every 25 hours on a Stinson, that kind of gets pricey. So I bought the Challenger adapter. It spins on. We did that with a field approval. You take it out and clean it as many times as you want. It's got a a real fine mesh stainless screen in it. It's got some high capacity Alnico magnets cast in the inside, so any ferrous metals is going to stick to the magnet. You take it out and just clean it off with a can of brake cleaner, put it right back on. And that housing is less than $300. So it doesn't take a lot of oil changes to pay for it.
Dave, brings up a question. Tempest oil filter, I was always under the impression that they had a magnet in there. I ripped mine apart and I found out there is no magnet in there.
No. No. Originally, my airplane had a 35 amp battery under the pilot's seat. Way back in the day when you used to put acid in them, that was about the dumbest place you could put a battery in the cabin. They went to the sealed Concorde and Gill batteries that helped. I was trying to strip as much weight off of this as I could, so I did a field approval, putting the Odyssey PC680 on the firewall. Eliminated all the old original heavy wiring battery box. The longest strip of high gauge wire on the airplane is right there. It's about 6 inches long. Took 26 pounds off the weight of the airplane. And that little battery will spin it like there's no spark plugs in it.
Taxi that thing with the battery?
It'll taxi on the battery. The guys are laughing at me, but I proved it. Get it spinning and let go of the brakes and it'll move it. Got to put a little chrome on it. It's got to look good.
Yeah, it's 5 knots, right?
Or more. This is the engine that we were talking about earlier. The 210 horse Franklin engine came out in '57 for the Bell and the Hiller helicopters. If you can find one, there's a whole bunch of really, really good parts that'll fit the 165s in it. Okay, tools. You're only going to need a handful of tools. Frank Bailey did a really, really good job manufacturing replacement Franklin tools, but he's not doing it anymore. He retired. So there's some commercial equivalents that'll do the same job. The flex socket's a Snap-on TMU 161, 1/4 inch drive, 1/2 inch flex socket. The ones on the bottom are just standard Craftsman 1/4 inch sockets. Cut the open end down to where it just encases the head of the bolt. Those are for the intake manifold logs, the ones that are real bare to get up in there and get. With those two tools, you can whip them in and out in nothing. Again, there's some up here. You guys can come look at them afterwards. That's the flex socket going up, doing the left. Then a little breaker bar with the cut down socket. You got all kinds of room in there to work with them then. Split lock washers. We'll go back to the intake manifolds. Whenever you guys change the oil in the airplane, it's a good idea to go around those manifold bolts and check them. The original washers are the ones on the right, the internal lock washers. Put one of those up under there. They don't do well going into aluminum or magnesium castings. They come loose. It's not uncommon. You get an intake leak somewhere, you go looking around it, and you got a bolt missing or 2 bolts missing. We've used the 338-45s, which are split locks, mil-spec washers, but they got about a 1-inch turn on that bolt before they're completely compressed. So they're not going to come back out of there. Any of the engines that we've ever put the split locks in, I've never seen an intake manifold bolt coming loose again. These are the original factory pushrod tool installer and removals. You can tell by the complexity that they're built for the military. They work well, but they're real complex. Frank Bailey was making them for a while. They're real scarce. They're hard to find the original ones. This is one that I came up with. I made the split collar. You thread the rod down in the middle of it. The long tube surrounds the pushrod tube opening at the cylinder head. Then there's another nut. You thread that down to expand it into the little groove in the pushrod tube. Drop that cup on there, and then there's another nut on the top. Turn that down, and it just pulls the pushrod tube right out without damaging it.
We've got one of the original ones, if somebody's doing it and wants to borrow it.
This is another original one that does the same job. There's one up here. Lyle Tool Company made it forever and ever. And it was for taking the lifters out of a big block Ford. Just happens to fit right in the pushrod tube shroud. It's got a slide hammer, you can pull it right out. They quit building it a few years ago. They sold the dies to Jegs Performance Products. That's the new part number. There's one up here if anybody wants to look at it. About 25 bucks. That'll pull the pushrod tubes out, no problem. Top tools, the Franklin, built for the military, the original lifter bleeding tool. Real scarce, hard to find, hard to use. 1/4 inch chain link with a section cut out, and a number 3 screwdriver does the exact same job. How many of you guys have ever bled the lifters on your engine? Check the dry clearances. Yeah. You don't have to do it every 100 hours, every few 300 hours, check them. What happens is the valves and the valve seats, when they wear, the valve will recess farther up into the cylinder, which lets the valve stick out through the valve spring farther, and it closes up that gap, that clearance, gets tighter. Loose is okay, tight you don't want because it'll hold the valves open eventually.
What's the like 40,000s?
40,000s, yeah. Craftsman socket, old school Craftsman. That's the right part number if you ever find one on eBay or garage sale or something. It's got the hex built into the head of it. So that gets up there to do that front right spark plug. You can drop it up onto it, put a wrench on it, and take the spark plug in and out.
Does it have a magnet in it?
No. The only one I know has got a magnet is that $70 Champion socket for the 18 millimeters. Anybody's going to work on their engine pulling valves and valve springs out. This is out of a General Motors Buick V6. We just stumbled onto it. That's the part number. It's K&M Tools, Kentmore. Current production, you can buy them, 15, 20 bucks. Put a 3/8 breaker bar in the star end of it. This goes underneath the head. Pull the rocker off. That goes underneath one of the 3 5/16 bolts. You push down, take the valve springs off to disassemble a cylinder. On the right's original Franklin cylinder base wrenches. Again, built for the military, big, complex. On the left is 2 snap-on torque adapters and a 12-inch 3/8 extension, does the same job. Current production. That's the 2 part numbers for them. One's for the 9/16, one's for the 5/8. That's how you torque the cylinder base nuts. The curve wrench on the top is called a starter manifold wrench. Snap-on makes one, a Craftsman made one. Between that and the 9/16, 5/8 old school Craftsman box end on the bottom, you can take any of the cylinder base nuts off on a 150, 165. That'll reach all of them. Cable tensioner. Has anybody ever checked the cable tensions on their airplanes? We found this tool. They use them for tensioning sailboat wires. You can buy them in all different ranges. They're about $120 a tool. But you can get one that falls into the range for the Stinson. Proper stack up for putting the prop bolts in. This is for the metal prop. Torque is published up there. This was a revision. If you look down on the very bottom left, it's hard to read from there, but this document was published in 1999. The Stinson manual calls out for the torque for a wood prop because when that manual was published, that's all there was. The early version of this document from Univer called out for 51,000 safety wire to safety it. That's like baling wire, trying to twist it with a pair of twisters. You got over 100,000s with 2 strands. So they revised it, and the new 99 published calls out for 0.041 safety wire. Yeah, you spin it good enough, it'll smoke. This is off one of the publications that Univer sold. This manual is a copy of some FAA specifications, STC list, and AD notes pertaining to the Stinson airframe. While periodic attempts are made to include updated or new material, no guarantee is given or implied that this book contains all the information or airworthiness directives that may apply to your specific aircraft. Engine propellers or accessories for aircraft annual periodic inspections. Please use current FAA publications. So it's like that big vicious cycle about using current data, not the original 1947 publications. think that's it for the airframe, if anybody's got any questions. Yep.
That's an interesting thing, one idea that I see mentioned a lot, mid-planes, the piece that goes on the wing for the drip.
The drip strip?
Drip.
Yeah, there's a drip AD node on the bottom of the wing for the drip strips. Should be right at the radius, at the inboard end of the flap. It should be a one-time AD node inspection. You walk up and do a pre-flight on the airplane, it should be there. And what that does, it stops any spilled fuel from running down into the fuselage inside, past the wing root fairing. A lot of the AD notes are one-time. There's really no recurring compliance on the airframe. It was all a product improvement thing. I mean, you get the one about if it's got ashtrays, they have to be the self-contained type, or you got to put no smoking placard in the airplane. Back in the 40s, I guess people smoked in the airplanes. At the same time the fuel was dripping. So, anybody got any questions?
Hey, you talked about intake nuts and washers, what are you using on exhaust?
Exhaust, we use the brass, and I use that same washer on it.
That
Split lock washer, and they tend to stay put then. Yeah.
You use long brass nuts,
Yeah.
but not the short.
Yeah, you can buy an extended length exhaust nut that actually sticks out. It'll bury the threads. Put the anti-seize compound on it, put the washer, and then run the nut up tight. And you won't have that buildup from rust on the exhaust stud when you're trying to take them off, and it won't try to pull the stud out of the cylinder head. So you get the long nuts, and then you run them up there. You don't see any of the thread from the stud anymore. It's buried, so it stays clean.
Yeah, we had a problem with we had a one side exhaust rebuilt and they put a lot thicker flange on it.
Yeah.
Obviously to keep it from warping, but then the nuts seemed excessive. There was not enough thread on
Yeah.
the stud.
Yeah, so you probably end up having to take them out and put longer studs in them. Yeah.
Dave, will you just mention a little bit about their business and what you do and that sort of thing?
My primary is I've got a helicopter company in Detroit area, run a bunch of Bell 47s. The Franklins I've been overhauling and maintaining for 45 years. The Stinsons probably since the mid 80s. I've got probably a dozen airplanes I look after for customers, and then we do a lot of engine cylinder overhauls for people all over the world. I've got a bunch of customers overseas in Canada, but it keeps me busy. No other questions? Thanks. Jody, I'll turn it back over to you.